Assalamu alaikum. Welcome to EEEAN. We are in DC Circuit lecture series part 4. Today we will discuss about the topic node, branch, loop and the identifying technique of series element and parallel element. I think you will get a clear idea about the topic node, branch, loops by following the video. So let's go. Branch. A branch represents a single element such as a voltage source or a resistor. At first, we have to know the term element. Every voltage source, current source or resistance is an element. In an AC circuit, the term capacitor and inductor are also elements. For example, look at this circuit. The 10-volt voltage source, 5 ohm resistance, 2 ohm resistance, 3 ohm resistance and the 2 ampere current source. These all are elements. According to the definition of the branch, we can say the number of elements equals to number of branches. In this circuit, we see there are total 5 number of elements. So we can say the total number of branches equals to 5. And we have a task for you. You have to say how many branches in this circuit shown in the bottom. Pause the video and try yourself. In the circuit, the resistance is an element, the inductor is an element, the capacitor is another element. So we know the number of elements equals to number of branches. Then that's why the total number of branches equals to 3. What is node? A node is the point of connection between two or more branches. Look at this circuit. The point A connects the two branches, the resistance and the inductance, and the point B connects the two branches, the inductor and the capacitor, and these 2 points A and B are the nodes of this circuit. Let's go to see another example. In the circuit, the 10-volt voltage source and 5 ohm resistance are separated with a point A, node point. The point B is a connection between the 5 ohm resistance and the 2 ohm resistance. Since there are no element in these 3 points, that's why we can consider it as a single point. Since there is no element between these points, so we can consider as single point. That the circuit has 3 nodes, the node A, B and C. Let's go to see another example. In this circuit, the 5 ohm resistance and the 10 volt voltage source are connected between the point A, and here is the another node point B, which separates the branches 5 ohm resistance, 2 ohm resistance, 3 ohm resistance and 2 ampere current source. And the another connection point is C, which separates the branches 10 volt voltage source, 2 ohm resistance, 3 ohm resistance and 2 ampere current source. So we can say that this circuit has 3 node points, node A, B and C. What is loop? A loop is any closed path in a circuit. Look at this circuit. There are 3 closed paths. That is, the number of loops in the circuit is 3. Consider these loops are L1, L2 and L3. In a loop, the current starts flowing from a node and after rotating it returns to the starting node. Look at this first loop L1. In this loop the current starts flowing from the node A, then goes to node B, C and finally it comes to the starting node A. That's it completes a loop. Similar incident happens in the loop 2 and loop 3. In these loops, the current starts flowing from a node and after rotating it comes across the starting node. What is independent loop? If there is any independent element in a loop, then that is called an independent loop. Look at the loop 1. In this loop, the 5 ohm resistance and 10 volt voltage source contributes only the loop 1. That's why this loop is an independent loop. But look at this loop 2. In this loop, the 2 ohm resistance and 3 ohm resistance both are not independent elements because the 2 ohm resistance contributes in both loop 1 and loop 2 and the 3 ohm resistance contributes in both loop 2 and loop 3. That's why there is no independent element in this loop. So we can call the loop 2 as is not independent loop. But the loop 3 is an independent loop. 3 ohm resistance is not independent element. Current source is an independent element because it contributes only the loop 3. Let us to see another example. In this circuit there are 3 closed paths. So we can say that there are 3 loops in this circuit. How many independent loops in this circuit? First we have to see the loop 1. We can say the 10 volt voltage source and 5 ohm resistance are independent elements because they contribute only on the loop 1. So this loop is an independent loop. The loop L2 is not an independent loop because the 2 ohm and 3 ohm resistance contributes in two loops. The 2 ohm resistance contributes in L1 and L2 and the 3 ohm resistance contributes in L2 and L3. Since there is no independent element, that's why the loop 2 is not an independent loop. But the loop L3 is an independent loop because the 2 ampere resistance is an independent element which contributes only on the loop 3. And see another circuit. In this circuit there is no closed path. That's why there is no loop in this circuit. The current starts flowing from the starting node but it does not return into the starting point. That's why it cannot complete a loop. So we can say that the circuit has no loop. A network with B branches and nodes and L independent loops will satisfy the fundamental theorem of network topology, that is B equals to L plus N minus 1, where B equals to branches, number of branches, L equals to total number of independent loops and N equals to total number of nodes. And let us going to see series element. What is series element? If two elements share only a common node, then we can say that these two elements are in series. Let us see this circuit. Resistance and the inductor has a common connection point. That's why these two are in series. Similarly, the inductor and the capacitor has a common connection point. So these two are also in series. So we can say that the resistance, inductance and capacitance are in series in this circuit. What is parallel element? If two or more elements share two common nodes, then we can say that these elements are in parallel. In this case, one terminal of the elements should be connected to the one node and the other terminal of the elements should be connected to the other node. For example, look at the circuit. In this circuit, the 2 ohm, 3 ohm resistance and the 2 ampere current source are in parallel because these three elements has two common nodes, node B and node C. One terminal of these elements connected in node B and the other terminal of these elements connected in node C. And the 10-volt voltage source is not connected in parallel because though one terminal of this voltage source connected in the common node C, but the another terminal of this source not connected in the node B. That's why it's not in parallel between those three elements. The same current flows through the series elements, but their individual voltage is different. The elements connected in series, the current flow through these elements is similar, but the voltage across these elements may be different. Look at the circuit, the 10-volt voltage source and 5 ohm resistance are in series. So, since these elements are in series, same current flows through these elements, but their individual voltage is different. And the second point, the elements connected in parallel have the same voltage rating, but their current is different. In the above circuit, the 2 ohm, 3 ohm resistance and the 2 ampere current source are in parallel. For this reason, the voltage across these three elements are same, but their current may be different. Number of branches and nodes in the circuit shown in figure. Identify which elements are in series and which are in parallel. Look at the circuit. In the circuit, we can see there are four elements. We know the number of elements equals to number of branches. So we can ensure that the total number of branches in the circuit equals to 4. We have to identify which elements are in series and which are in parallel. The 10-volt voltage source and the 5 ohm resistance are in series because they have only a single connection point, node A. The elements 10 volt and 5 ohm resistance are connected in series. On the other hand, the elements 6 ohm resistance and 2 ampere current source are in parallel because they have two common node points. The one is node B and the other is node C. So we can say that the elements 6 ohm resistance and the 2 ampere source are connected in parallel. Let us see the another example. How many branches and nodes does the circuit in figure have? Identify the elements that are in series and in parallel. From this circuit, we see that there are total number of elements equals to 5, that is 1 ohm, 2 ohm, 5 ohm and 4 ohm resistance and the 10 volt voltage source. So we can say that the total number of branches equals to 5. Circuit, there are 3 nodes, node A, B and C. There is no elements between these similar points, so we can consider this as single point, node A, node B and node C. And then we can say that the 1 ohm and 2 ohm resistance are connected in parallel because one terminal of The 1 ohm and 2 ohm resistance are connected in node A and the other terminal connected in node C. That's why we can say these two elements are in parallel. Similarly, the 10 volt and 4 ohm resistance are also connected in parallel because one terminal of these two elements are connected in node B and the other terminal of these two elements are connected in node C. I hope you all are understand about this topic. See you in the next video.